Question 5, let v equal dx dt. So now we can say that dv dt is equal to d2x dt2, which is what they give us. So we can replace that with dv dt is equal to, we call dx dt v, so v squared. So, oh, don't forget about the plus 1. So dv over v squared plus 1, this makes a big difference to the question. If the 1 isn't there, we could just integrate v squared, but let's see what v squared plus 1 becomes. This is equal to dt, so I'll put a 1 here, and if we want to integrate 1 over v squared plus 1, it's not the same as 1 over v squared, and we're told dx dt is equal to 0, so v and 0, t is equal to 0, t and 0. So when we're integrating 1 over a squared plus b squared, or a squared plus x squared, this is what we have here, our 1 over v squared plus 1 squared. So we have 1 over a by the inverse tan of x over a. So this is going to become 1 over 1 by the inverse tan of x, which is v, over a, which is 1. So this is just going to become the inverse tan of v between v and 0. We integrate dt, we get t between t and 0, so this will be t minus 0. So we get the inverse tan of v minus the inverse tan of 0, so just 0 is equal to t. So that means that the tan of t will be equal to v, or inverse tan of v equals t. So the tan of the right hand side, the tan of t is equal to v. So that leaves us with, let's rewrite dx dt now, which is v, so dx dt is equal to tan t, my original v, with what I saw v to be. So dx is equal to tan t dt, so we need to integrate, and x is 0 when t is 0. So we're going to get the integral of dx, which is x between x and 0, equal to the integral of tan t. Well, let's see what tan becomes. So you can see from the bottom, tan t becomes the natural log of secant x. So this is going to give us the natural log of secant x, sorry, secant t in this case. And that's going to be between t and 0. So we're going to get x minus 0 is equal to natural log of secant t, and then the natural log of 0 will be 0, so just this is our answer now. X is equal to the natural log of secant t.